Okay, welcome to our next video. It's in section 1.2, displaying quantitative data. So we were talking about qualitative data before. We were talking about our graphical displays with bar graphs and pie charts, and now we're going to talk about ways that we can display quantitative data. And there is a difference. So why are different types of stem plots needed? Well, that's our essential question for the day. Let's look at different types of graphical displays for our quantitative data. We have a dot plot, and a dot plot is great for whenever you have data sets that don't have a very large range in terms of the number of values that they could possibly cover. And it uses the actual data values that you can see, all of them at once. So that's a use for your dot plot, is the fact that you can see all of your data at once in a pictorial form. But it's best for whenever the range of your values is small. And then we can have something called a stem plot, and there's many different types of stem plots. So our stem plot includes the actual numerical values, and it's best for small numbers of observations. And I want you to notice in your notes, I'm sorry, that A and B are swapped. So just change the names of A, make A into a stem plot and B into a dot plot, and fill in your notes that way. Our stem plot also includes numerical values instead of dots, and it's best for small numbers of observations. So you don't want to include a great number of values there, but it can go a wider range than a dot plot, and it will still be useful. And whenever our quantitative data does not fit into one of those two categories, a small range or small numbers of observations, then it's best to go with a histogram. And we will talk about histograms tomorrow. But today, let's talk about our dot plots and stem plots. And we're not going to go too far into this today. We're going to actually work with our practice tomorrow. But let's talk about our first example that's in your notes. So students in a high school statistics program were asked to report how many siblings they have, and the data is listed below. And it looks like a whole lot of data, but what you can do is construct a dot plot in order to show this data and how spread out it is. So the easiest way would be, first I see that my range of values is from 0, and then the highest one that I see here is 7. So I'm going to go ahead and number my number line. Sorry, the number line here doesn't look as beautiful as it does in your notes, but I'm going to let every 2 spaces indicate a value of 1. So this is maybe 0.5 and this is 1. And it doesn't make sense in terms of 0.5, in terms of number of siblings that someone has, but just so that I can use my entire range here on my number line for my dot plot. And so then I started counting the occurrences of those values. So I start with 0, and I see 1, 2, 3, 4 occurrences of 0 in that set of numbers. So that I put 4 dots above the 0 on the number line. And then I'm going to look at the ones. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 ones in this set. So I made 15 dots over the number 1. And then I see number 2. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now I put 13 dots above the 2. And then for number 3, 1, 2, 3, 4, 5 dots above the 3. For the number 4, we see 1, 2, so 2 dots above 4. For 5, I see 1, 2 occurrences of 5, so 2 dots above the 5. And finally, we have 1 occurrence of 7. So 7 gets 1 dot on its own. Notice no occurrences of 6 happened, so there are no dots on 6. So this is what would be called a gap in our data. Now, we're going to get into later how the shape of this data is and what we can call the shapes, what the shapes mean, the existence of gaps, and things called outliers. But just for now, let's concentrate on looking at where the majority of our data is. So it's asking how many siblings does a typical student in the class have? Justify your answer. Well, a typical student in the class, I'm going to first look at the majority of students. The majority of students in the class are having either 1 or 2 siblings. The number of students with 1 sibling is 15, and the number of students with 2 siblings is 13. So the majority of the students in the class have one of those 2 values of data. So I have that most students have 1 or 2 siblings. The median number of siblings is 2, and the median would be the middle number. So if I lined up all the numbers end to end, the very middle number is a 2. And 28 out of the 42 students listed here, so well over half, reported here have 1 or 2 siblings. So I'm going to say that a typical student in the class has either 1 or 2 siblings. Okay, are there any really unusual values in the data set? And explain that. Well, I noticed a gap earlier between 5 and 7, and then all of a sudden there was 1, 7, all on its own. So the student with 7 siblings stands out from the rest of the data. There is a small gap at the end between it and the rest of the data. So it appears to be what's called an outlier. So when we're talking about describing our data and how it is distributed, we would need to talk about the shape, the outliers, the center, and the spread. Well, we've talked about the center. That's where the majority of it seems to be, and that's where we have 1 or 2 siblings as being our measure of center. And then we have a gap here. We have the shape that has a hump on the left with kind of a tail towards the right. And again, we'll get into more of what these shapes mean later. And 7, I would call an outlier here. Of course, we're going to get into what really makes something an outlier or not later. So, but that would be all reasons to talk about this graph. Now, the next example that's in our notes is something that we're going to have to do together in class. So make sure you bring your note guide to class tomorrow, as well as your book. You are going to be doing some of the problems that are in your book, so please bring your book to class. And that should be all for today. See you tomorrow.